Okay, so exponential functions from yesterday, we were always doing exponent comma result. So we always had a horizontal asymptote. Okay, it was on 0 unless there was a shift up or down. And we either did an increase or we could do a decrease. Okay, that's an exponential shape. Okay, the increase or decrease depends on your base or if you had a reflection, something like that. Okay, so let's talk about logs. What do you think I'm going to do different with logs? Okay, so think about when I say what is 3 squared and then you repeat to me that's 9. You're giving me the result. Now with logs, you're giving me the exponent. So the logs are going to go results and then the exponent is the answer, like an input output. Okay, so what did I do here? I've switched my x's and y's. Does anybody know the name of that? Because we studied it in transformations. What was that called when we switched the x's and y's? It's that inverse. It's that inverse, and it reflects over the diagonal x, y equals x. Yep, inversing. Okay. All right, so guess what's going to happen? The domains and the ranges are going to be reversing. The horizontal asymptote is going to become a vertical asymptote. Okay? And we're either going to kind of do an increasing or a decreasing function. Okay, so that's the gist of it. That's like a main idea. So exponentials, horizontal, asymptote. They have a y-intercept. Logs will have a vertical asymptote, and they should have a x-intercept instead of a y-intercept, right? Everything's just switching. Domains and ranges will switch. Right? Okay? X and Y switch, domain range switch. Asymptotes switch horizontal to vertical. Okay? Obviously transformations are going to do things that are different, right? But this is just the main idea. All right, so we're going to graph both y equals 3x and y equals log 3x. Okay, so here you can see the difference. In this situation, x is the exponent. In this situation, x is the result. Okay, so I'm going to start both graphs the same. 3 to the negative 1 equals 1/3. 3 to the 0 equals 1. 3 to the 1 equals 3. This graph will have the coordinate negative 1 comma 1/3. But the log graph will have the coordinate 1/3 comma negative 1. So I started the same way, I just decided to write my coordinates in a reversed order. So this one's going to have 0, 1, but this one is going to have 1, 0. 1, 3, 3, 1. Okay, exponential will have a horizontal asymptote. Log will have a vertical asymptote. The base is 3, so we will increase. Okay, so that's the foundation. Does that make sense? So this is called y equals 0 for an asymptote, unless there is a d shifting it up or down. This is called x equals 0 for an asymptote. What's the way that I could change that? C. Could move it left or right. Okay? Because this doesn't change if I move this line up or down. That doesn't matter. But if I move it left or right, it would matter. Okay? All right, here we go. We're going to graph this. So my first question is this. What is the base? Your answer should be that the base of this is 5. So we do what? 5 to the negative 1, 5 to the 0, 5 to the 1. Okay, now I did the same thing with an exponential, the start, but now my points are reversed. So the coordinate would be 1/5, comma, negative 1. Result, comma, exponent. Just reversing this from yesterday. So there's my 3 coordinates that I'm going to work with. Okay, but we're going to do some transformations. We have a negative in the front, so that is a A. And we have a number connected to the X, so that is a C. So what should I do to my coordinates? Okay, so I'm going to be doing a right 2, add 2, and I'm negating the y, reflecting. All right, so here we go. I'm going to go all my x's. 1/5 plus 2 is 2 and 1/5. 1 plus 2, 3. 5 plus 2, 7. The opposite of negative 1 is positive 1. Negative 0 is still 0. Negative 1. Okay, and then we can't forget there's a vertical asymptote. So normally it's in the center, but guess where it is now? What happened to it? It'll have moved right 2. So should we put that on there already? It'll have moved right 2. So when you draw your shape, it should be based around that asymptote. So 2 and 1/5, comma 1, 3, 0, 7, negative 1, Okay, number 2, example 2, I'm being tricky here. There's 2 things I'm being tricky with. The first thing I'm paying attention to is the format of it. Format of the transformations. Anybody know what's the problem of my transformation? Right? We always have to have our transformation. If we have a b value, what has to happen? It has to be factored out. So that was my first trick that I was trying to get you on. Transformations, we always understood b out. Okay? Second trick. There's no base down there. It doesn't have a base at the bottom here. Do you remember the secret base of a log? 10. Okay, so there we go. So if our base is 10, I need you to do what? I need you to rip me 3 points using a base of 10. Since this is a log, how do you write your coordinates? Results, comma, exponent. Results, comma, exponent. Those are the 3 original coordinates. Okay, we're going to transform them. We have to do that, and we have to do that. So I'm going to call this a B, and I'm going to call this a C. So we are going to go x divide by -1 plus 4. And y, just y. I'll make you guys a deal. I'll do all the math on the y values, and you can do them on the x values. Does that sound like a good deal? And I'm done. Okay. What is -1/10 plus 4? Or what's 4 subtract a 10th? 3 and 9/10, right? What's -1 plus 4? 3. What's -10? Right, I'm negating it. What's -10 plus 4? -6. Okay, so we have to have a vertical asymptote. Where? Was there anything that moved it from the middle? Yeah. It's at 4. It got moved 4 to the right. So there's my vertical. Ooh, I'm sorry. Hopefully yours looks better than mine. Okay, I should know the direction. Why? Because normally logs go that way to the right, but that -b caused it to be going that way instead, right? That's that reflection part. Okay, last question in the book, I think, for this. Yep. This is our last question. So the ln function is called the natural log. Erica, you French immersion can be like log au naturel. The L and then the N. I don't know. Natural log. Log au naturel. That's what I always say. Okay. It's the same thing as doing a log with a base number that's secret. Do you remember this one? It's a little special. So this one is an E. Okay, so we had two secrets. When we see a log without anything, there's really a 10 there. But when we see a natural log, it's really using this E value. Okay, so my base is E. So here you go. E to the -1, E to the 0, E to the 1. Okay, so this, you can have your calculator on because you don't know how to just use that number. So let's see, we haven't probably even looked for this button. It's a different button you've never used, I'm guessing. Everybody will kind of have something different, I'm guessing. Mine, I have to do a shift on. And I think everybody's calculator, no matter what, when you push it, it activates an exponent. Does everybody's do that? E to the, and it like puts an exponent up there. Okay, so -1. Okay, so you know how I normally say you have to round to 3 decimals? Okay, am I going to understand that on a graph? No, I don't care on a graph, right? So I'm going to just do 0.4. Okay, it's a graph, so I don't really see 3 decimals when you graph something. Okay, you don't need a calculator for this one, sorry. What's E to the 0? 1. Everything to the 0. And then this is the value of E. Just like how we had a value for pi, this is the value for E, 2.7. Okay, can you write me the original log coordinates? So you have to do log in an opposite way, results, comma, exponent. Okay, so I got 3 original. We got to do this, and we've got to do that. So I have to do an A and a C. So x plus 2 would be the C. -y is the A. Okay, and also before I graph my coordinates, it might be just a good idea to put my asymptote on there. Where is this vertical asymptote going to be? At right 2, x equals 2. If they ask you questions on the exam about just what's the equation of the asymptote, x equals 2. Okay, so this is the provincial document graph, minimum of 2 coordinate points. On your logarithmic function, you have to show your x-intercept and your asymptotic behavior on that vertical asymptote. Those are the things that they're looking for on the provincial. Okay, which we've covered. I like to stick to the 3 points, but I guess 2 is the required number. Okay, graphing a log function. So this question says, what's the x-intercept? Okay, what's the definition of an x-intercept? You should always do what, no matter what graph you're on? Make y 0. So here I go. I made the y 0. Okay, I'm going to talk about my 3 components. What is the actual base down here? E. This is the what? The result. This is the exponent. Can you move all that stuff around? It's log right now. Can you change it so it looks exponentially? Base, exponent, result. Base, exponent, result. See how I moved it? Base, exponent, result. Good? Okay, no calculator. This is on a multiple choice. Multiple choice is the second booklet of your exam. No calculators allowed. Okay, what is anything to the 0? 1. How do you isolate x? Add 2. Is that one of your answers for an x-intercept? Okay, question 2. What are you going to do on the exam as soon as you see the word explain on a question? You got to write words to me. So this is an exponential function. This is a log function. Do you notice how they both have the base of 3? Okay? They both have a base of 3, so that's in common. So this is going to have coordinates that will say exponent, comma, results. And what would the log graph have? Results, comma, exponent. So what could we write as a sentence? How can you use the graph of this to take maybe the coordinates and change it to that? So you could say, take the coordinates on the graph y equals 3 to the x. Take the coordinates off of that graph, and how could you use that to graph this? Take the coordinates on that graph and, should we say, switch x and y? Okay, so there's I had to write words. So I said to take the coordinates off of this graph, and you're going to switch the coordinates around. Okay, you could have also talked about reflecting it diagonally. Reflect the graph. You could say that would have been a good sentence. Take the graph and reflect it diagonally over y equals x. Okay, that's the properties of inversing, switching x's and y's. Okay, does everybody remember? So if I do this, which is an exponential, here's your reflection of y equals x. And now this is a log. Do you see the reflection that happened? This is an exponential and this is a log. That's what they're doing, reflecting diagonally. Okay, so on page 5, this is a what kind of graph here? What style of graph would this be? Exponential. That's an exponential graph. So you're going to figure this graph out on your own. But then it says to graph the, and what does this symbol mean? Inverse. So how are you going to graph the inverse? You're going to take all the coordinates that you did on this, and what are you going to do to the coordinates over here? Switch them, okay? That's it. And once you've done that, what do you think your graph is going to look like? It's going to be some kind of log graph then, right? Because this was exponential. Graph it, figure it out, but then over here just switch the coordinates. Okay, and this is my last question I'm going to help you with. Explain, words, we got to do words, why the domain of this is x is greater than 1. Okay, who remembers what I told you on the 2 days ago about a log with the base exponent result? I said there's something that always has to hold true in a log. Do you remember what it was? It was something about the result of a log. What did it always have to be? Positive. So I would have to write a sentence. The result of a logarithmic expression, always has to be positive so therefore x subtract 1 has to be mathematically, how do you write positive? Greater than 0. Thus, if I algebraically just maneuver that, it's telling me that x has to be greater than 1. Okay, but this is my explanation in a word because it says explain. The result of a log always has to be positive. Okay? And that is why when we talked about our original log, look at the domain. The domain is only positive x values. It doesn't touch 0. You can't be 0. 0 is not positive. Your domain is what? 0 to infinity. Positive on a log. Okay? I feel like there was 10 questions related to that on the last exam. So, results of logs have to be positive.